Well, good morning, everybody. Now, if this was my classroom, I would be absolutely thrilled with a nice big screen. I've been to many, many classrooms now which have tiny interactive whiteboards, and the kids at the back can hardly see anything. So big screen for me, and also I don't particularly like being behind a podium. I like to be out and about, which is where these things come in. You can control the IT from anywhere in the room, and you can throw it down on the desk, and the kids can have a go. So that's a bit of technology I wouldn't be without. Let's just see. So getting the classroom right is the first thing. If we're going to implement this change. Oh, by the way, Kim Hu, if I'm talking too fast, will you please wave? Where's Kim Hu? Probably can't hear me say that because I'm saying that too fast. Sorry about that. Okay. So for most of my life, most of my teaching life, I had just me and a piece of chalk. That is me, by the way. Well, it probably isn't, but I think I did a pretty good job with the clever ones. But the next layer down, they peeled away, and they couldn't see what was going on. So what's new? What came new? Well, I think two things. The data projector, fantastic innovation, so they could all see things visually. But the internet, of course, is the first thing. So taming the internet is the first point I'd like to make. How can you do this? Well, obviously, you've got Google. We've heard about Google already. Doing some stats work with age and body mass index, for example. I just put into age, BMI, you get lots of websites about an airline. Well, okay, but if you go to images, oh boy, all of a sudden it's lots of mathematics. That's amazing. So that's a nice use of Google. Taming the internet is something that I've been spending a lot of time on. So my own website tries to make sense of it all by putting it into different categories and lots of different web broadcasting for the busy teacher. I even have a list of apps for the iPad. It's not a very long list, I have to say, for secondary maths yet, but hopefully that'll grow. And up here, calendar events. But the main website, I'd move it into maths education, classroom resources, and mathematical entertainment. Those are two words you don't normally see in the same sentence. But there, for example, I try to keep up to date. Launched today is Google Numberphile. Keep up for that. A chap called James Grime is coming to our TSM workshop. He's launching this today. So look out for things that are always new. Then I thought we'd use the web to find a nice real parabola, something you can do now just by zooming in. Now, if you know where to look, you can find all sorts of things on the web. And here is this extraordinary structure. It's about 100 meters long and 10 meters tall. It is a parabolic sound mirror. Is it parabolic? Well, we can explore it, of course, in software. We can just have a look at this and vary the various parameters. We can mark off the point where the sound appears to be bouncing off and arriving. And then you can see incredibly that wherever the sound comes from, it ends up in the same place. What a wonderful way to show the focus properties of a parabola from a real parabola. Then I thought, if we're going to adjust the curriculum to take account of the computers, maybe we could welcome some old favorites back. So what about complex numbers? Perfectly understandable if you have the right visualization. So here's our old friend, the quadratic. We've been talking about it quite a lot today. And of course, as you move C up, suddenly we're told these roots go imaginary. You have to imagine them. Well, not anymore. Because if you just move around, you can see that actually those complex roots are part of another orthogonal parabola. Some people call these the phantom parabolas, which I think is wonderful. All curves that have complex roots have phantoms. Would you like to guess what the phantom of the cosine curve is? It's cosh. Now, isn't that fabulous? What about differential equations? Yeah, I mean, a lot of people can understand the principles of generating a differential equation but can't solve it. But of course, the computer can solve it now, not a problem. Just put in the first Newton's second law, mg minus kv to that equals mv dashed, and you've got your terminal velocity being shown beautifully. It's in the news all the time. Every time those people fire guns into the air in Tripoli, what's happening to those bullets? Well, hopefully they're going to reach the terminal velocity long before their speed becomes fatal on the way down. But it's an interesting idea. But if they fire them at an angle, not so good. 3D vectors. I spend all my time waving my arms in the air. Isn't it just wonderful that you can now have a look at, first of all, vectors in 2D, and then do exactly the same thing by just adding another dimension in 3D. And there it is. And you can have a look at two vectors. The sum of two vectors on a plane is always in the plane. I feel so I could sing a song about that. but that means you can define a plane as the linear combination of two vectors. So here we are, enter a vector plane, and there it is, and you get another vector, another plane. The central limit theorem, one of my favorites. I've done this with year 10s. Why is it that when you get on an aeroplane, they weigh your luggage, but they don't weigh you? Surely it matters. Well, I've found a whole load of weight data and plotted it up. And then very simply, you can use the sample means by having a look. For example, if you have a 5-seater Cessna, 5 people at random getting onto an aeroplane. Does it matter how heavy they are? My gosh, it does, yes. Here I've just got our first sample, and there's the average. Second sample, there's the average. This idea of central tendency, very nice to illustrate with a small sample. Take lots of samples, and you can see the standard error is over 8 kilos. Fantastic variability that the captain of that plane would be really worried about. What about the A380 with 400 people getting on board? Wow! Look at that distribution of sample means. It's razor thin. So of course the captain knows how heavy everybody is when they all get on. And that really matters. So it doesn't matter. They don't have to be weighed. So those are some topics that I think could come back. And of course none of this is any good whatsoever without the training. And that's the other thing that I spend a lot of my time doing, is training teachers. And I have my own TSM workshop. I happen to think that the eyeballing people is what really matters. There's a lot of possibilities for doing training online, of course. But our training has some quite celebrated guest speakers every now and again. And here we go. This was last summer. Lots of happy teachers being trained. But what really matters is all hands-on. I regard it as the opposite of conference. It's the opposite of this event. Everybody, the delegates, are doing all the work. They're bashing away for 3 days, and they love it. And it is, of course, the National Centre has also given its stamp of approval, which is nice. So those are 3 points I'd like to make. Try to make sense of web resources. It's all out there. Fantastic Aladdin's cave of resources. How can we adjust the curriculum? Can we bring these wonderful topics back? Yes. But can we train the trainers? Thank you.
Very good. Thank you.